Welcome, Matthew. It's a pleasure to have you here, giving an invited talk at the AI for Experience course at Stockholm University. We have a room full of students and some guests as well. And in this course, we have been using your book that was released in 2023. So we have been reading, I think it's chapter 2 and 3 together, all of us. The nodding is happening here. So it's great to have you. So please,
Yeah,
Matthew, from all the way from University of Alberta through the wonders of technology, welcome.
Thank you so much. Yeah, I'm very happy to be giving a talk. Excited to be talking with you all. So I'm going to be giving this talk on mixed initiative procedural content generation via machine learning. And don't worry, I will go through and explain what all those words mean if they're unfamiliar, though I suspect that at least some of you have heard some of them before. Real quick, who am I? There's me if I'm wearing a different shirt. So long ago, I was a producer at Zynga. Then I worked a bit at EA Sports. Then I went to get my PhD at the Georgia Institute of Technology, where I did a graduate fellowship with Unity and an internship at Disney Research Pittsburgh, which no longer exists. Rest in peace, Disney Research Pittsburgh. These days, I run the Grail Lab at the University of Alberta and at Amii, the Alberta Machine Intelligence Institute here in Canada. There's the Grail Lab, or at least a fairly recent picture. There's also Seth Cooper over here, who was a visiting professor at the time. There's a whole dang bunch of them trying to graduate them away and have fewer students. In terms of what we work on, in terms of the Grail, I should have said it's a backronym for Games Research AI and Learning Lab. We do about 55% of the research is on PCG, about 20% is on player or user modeling, and 25% is on core machine learning. So that's usually like explainable AI and transfer learning there. Okay, so let's get to this. Mixed initiative, procedural content generation via machine learning. Let's break this down a little bit. So let's start with PCG, though I think you're getting some lectures on PCG besides me, but I wanted to quickly go through what I think of when I think of PCG. So for procedural content generation, right, this is computationally representing a design process. So taking some design process, which is generally done by a human or some other process, and re-representing it computationally or algorithmically. There are people who will tell you, Tarot is PCG, for example. It has very large time and expertise requirements in most cases, right? You have to not only be an expert at the design task, but you also have to be an expert at computationally translating that design task. So it's pretty tough. Obviously, here's an image from No Man's Sky at launch, which had a very bumpy launch, but then got a lot better. It's sort of a representation of how it has this large time and expertise requirements. And about 95% of the uses of PCG, both in video games and the movie industry, because it shows up a lot there too, use non-machine learning approaches. So real quick, and when we're talking about PCG, we can think about the algorithmic generation of content. We can break that down into game bits, game spaces, and game scenarios. And I've stolen these terms from Procedural Content Generation for Games, a survey from Hendricks et al. Back in, I think, 2015, something like that, 2005. There's a 5 in there. Anyway, game bits is things like the guns in the Borderlands series, the trees of a speed tree, which is what I mentioned earlier in terms of being used in both games and film. If you've seen a Marvel movie recently and there was a tree in the background, that's a speed tree. If there was some cityscape in the background, that's a speed tree or related algorithm and tool. And then No Man's Sky, of course, generates a whole bunch of stuff in terms of alien creatures, alien worlds, etc. Game spaces, we can go back to Rogue, which is where the term roguelike comes from in 1989, though it's, or 1980, though it's not the first instance of PCG in games. That would actually be Escape from Appletree Manor in 1979, but we don't have Escape from Appletree Manor likes for whatever reason. We just have roguelikes instead, don't know why. Remnant from the Ashes, Spelunky, and of course this little game called Minecraft you might have heard of, all generate their spaces, their worlds with PCG. And then finally, game scenarios, right? This is like Skyrim's Radiant Quests, which are basically these very cookie cutter quests that you can get at the end of the game. Games like Dwarf Fortress and Cave of Cud generate their whole stories, their whole worlds, their whole quests, their whole histories via PCG. Little games like Elsinore, which I'm hugely biased on because some of my friends developed it, but have you basically able to completely alter the game scenario you're playing via your actions through a sort of planning-based PCG approach. So the most common approach, as it's not machine learning, is actually constructive PCG. And constructive PCG are basically methods that build up PCG content piece by piece. You can think about it like Lego or Diplo blocks, right? A human author generates a whole bunch of pieces and then writes rules for how those pieces can be put together, and then says, go forth, algorithm, and make me content, right? So you end up with slots that are filled by tokens authored by a human and constrained by rules. And it is by far the most popular PCG method among actual game devs and in the movie industry. Now, why would that be? Why is it so popular? Well, compared to other PCG approaches, it is one, more controllable. It's really easy to take the individual pieces of that or the individual rules and make changes to them to get a different effect. It's faster. A lot of PCG approaches require iterations or require cycles. You might have seen like diffusion models, which iterate up from some random state. This is much faster. It's one shot, right? And they're more intuitive for designers. So most designers are not thinking about a PCG problem in terms of like a distribution over things, are not thinking about a PCG problem as like a search problem. They're very used to thinking about a PCG problem or a design problem generally in terms of breaking apart into pieces, working on those pieces individually, and then putting them together. So it's a natural fit. Okay, so that's PCG. Let's talk about PCG-ML, PCG via machine learning. So the basic intuition of PCG-ML is what if instead of trying to author this design knowledge for PCG, so all those tokens, all those slots, all those rules, we had an AI learn it, right? Gasp. So this basic idea led to a whole bunch of us, you can see the title there, coming together in 2018 to write the sort of initial journal paper. And of course, you know about this book that the first three authors here worked on, including myself. And in that paper, we proposed some sort of areas of PCG and some potential things that people could work on in the future. We just basically identified the field. And you could basically think about this as us identifying what is now called generative AI. So, you know, your chat GPTs, your DALL-Es, your stable diffusions, your Midjourneys, et cetera, but for games, and we got there first. So we're allowed to keep on calling it PCG-ML, even if the press releases of these big companies would prefer the term generative AI. It's not even generative all the time. Anyway, so real quick, what is machine learning? So maybe somebody in this room is unfamiliar with what machine learning is, but it is basically function approximation. So rather than a human having to write the code themselves, we are going to have a machine attempt to approximate a function that does the thing that we want to do, right? So basically, let's assume there's some function, f of x gives us y, where x might be a news article, and y might be whether it's mis or disinformation, or x might be some random noise, and y might be an image, and et cetera, et cetera. Then we want to approximate that function, so f dash or f prime x of x equals y. And notably, this function that we want might be impossible. It may not actually be possible for us to do this. Like all the OpenAI people who are attempting to get AGI by putting in question mark and getting out AGI, artificial general intelligence. But if this function is possible, or can be reasonably approximated, so we can't get the actual function we want, but we can get something close, and then we can learn it. So in case this is unclear, and I find that for some students and some members of the public, and for some higher up people, this is unclear, you might be asking, hey, where does AI fit into machine learning? How about deep neural networks? How about large language models or diffusion models or whatever? Well, basically, artificial intelligence is the big circle. So this includes like the constructive methods that I just mentioned a second ago in terms of PCG. And within that is machine learning. So that includes deep neural networks, but it also includes other machine learning approaches like decision trees and Gaussian mixture models and et cetera, et cetera, et cetera. Anything where we're learning from examples or data. And finally, large language models or diffusion models or whatever are just a subset of deep neural networks. So this is a big area. And so the fact that we're just nowadays calling anything that's an LLM AI is quite annoying. Okay, so machine learning. We can basically break it into three classes, or Tom M. Mitchell can, and I agree with him. So the first of these is supervised learning, where we have lots of inputs X, lots of outputs Y, and we're trying to learn a function to map X to Y. So you can approximate Y prime for some new values of X. So this is the most typical version of machine learning. Unsupervised learning, on the other hand, given some inputs, we're going to attempt to learn a function to find categories or clusters, additional information, y, using some metric. So we don't actually have the y here. We're trying to approximate that from the data using some notion, some metrics of what is good. Finally, reinforcement learning. Given an environment, we're going to attempt to approximate a function going from states x to the optimal actions y based on observed reward from the environments or environment. Apologies. So these are your three main classes. You can mix and match, right? So these days you might have heard of RLHF, which is how they're training like ChatGPT and stuff. That's using first a round of supervised learning and then following it up with a round of reinforcement learning on the same model. So you can mix and match. So supervised learning, it's the most direct form of this sort of function approximation. You can think about three major factors that actually limit what functions we can learn here. So one is the architecture that says, what could we actually learn? The architecture is basically like the sort of vague notion of the space of possible functions. You know, we could translate a set of architectures into a set of code or programs rather. How we optimize that architecture, right? So how we're actually going to go about trying to figure out what's our final function from the set of possible ones, and then the data that we have. So PCGML use cases here would be if we have some examples of some kinds of content that we want, we can generate more of those examples, right? So, and things that are close to them. So this is things like diffusion models, this is things like stable diffusion, Midjourney, et cetera, but also stuff for audio, also stuff for game levels, also stuff for card generation, which Miriam wanted me to talk about, et cetera, et cetera. You can think about it like this, right? So the space of all possible learned functions is near infinite, right? It's anything that can be programmed. In that space, we have our architectural bias that says this is the space of functions that we're possibly going to be able to learn. Then from there, we have our optimization bias that says, how are we going to optimize this architecture, and our data bias that further constrain it down to just the sort of intersect of these two circles. And that's the only things that we could possibly learn. That's it. In the end of the day, random chance basically tells us where do we land in there, but there's some things that we can do to guide us one way or another. Okay, then there's unsupervised learning. I'm grabbing a picture from some Georgios Sandakakis work here. So this is identifying high order groups or secondary representation Y. We want to approximate from our data X and following some function F, right? So this is like clustering, things like that. You can think about it as being used to get some representation that we might use. So for example, if we want to have a condensed representation of game levels or condensed representation of music or of images or things like that, then unsupervised learning can be very helpful there. You can also use it for repairing content. So if we have a set of pieces of content, we can find what's the closest valid non-broken piece of content to repair it. And you can use it to summarize generative content. So we can generate lots of stuff, right? We could generate thousands of instances of data or of pieces of content, right? So to be able to generalize over that in some way is really helpful to be able to say, okay, these are the kinds of things we can output. Finally, reinforcement learning. This is the quintessential reinforcement learning figure in which we have some environment, generally a game environment, which is giving states and rewards to some agent when that agent takes actions in the environment. You can even see how low res it is because I've just copied it from elsewhere. But basically, in a PCGML setup, we're going to replace our environment with some kinds of content that we want to make. So the agent is making changes to this content to iteratively improve it, ideally. And then we're getting back the state, which is the new sort of setup of what the content looks like, and the reward of how good the content is, right? So we can basically use this to generate whatever, right? There was some recent work out of Clark Verberg's lab that was presented at COG on using this to generate roller coasters in Roller Coaster Tycoon. So you can use PCGRL for whatever, right? Okay, now we get to the final set of the words on here. Mixed initiative. We've done everything else. So mixed initiative basically means that we have a human and an AI system working together to create some sort of digital artifact. Now, I don't know how well this is going to show, but I'm going to try to show you a video example of a mixed initiative PCGML tool from that I produced during my PhD. So this is Morai Maker. So you can think of this like Mario Maker, if anybody's familiar with that, but we've got an AI in it. So you can see just then what I did is I hit the end turn button. And as soon as I do that, this sort of what I have done so far, which is make a little bit of ground here on the bottom left, that's going to be sent to a back end deep RL, deep reinforcement learning agent, which is then going to say what should be the next bit of content that gets added. So you can see here it's adding some bricks along the top of the screen. So that was it, not me. So by keeping the bricks, like I'm doing this here, I'm not deleting the bricks. By keeping them, I'm giving the RL agent a tiny little bit of positive feedback. I'm saying, yeah, that was good. I liked that you added those bricks. Next up, what I'm going to do is I'm going to create this little like island here. I'm calling it an island, but it's this little like separate area with just this pipe. I hit end turn again, partner thinking. That's the RL agent. So it adds more bricks because it knows I like bricks, but it also added this stair block up here. So I delete that, which gives it a small negative reward. It says, no, don't do that. Then we're going to do it again. So I'm going to give it a second example of this little island. By the way, this wasn't me like messing around with this a whole bunch. This was literally one run that I happened to record of working with this agent in this sort of mixed initiative tool. I also add those piranha plants. That doesn't do anything. That's just for me. The stair block there is not at all what I want. I delete that. So again, some negative reward. You give it this sort of partial third example of this little pattern, this little island pattern, and then it does this. So some more bricks, it added those bricks, but it also did this. This is really interesting, right? So it added all the right pieces, but in the wrong places, right? So we have these ground blocks, we have a stair block it added, and even one of these piranha plants, but it's putting them in slightly the incorrect places, but it's getting closer after like, what, 2.5 examples. That's pretty good. So I'm going to delete that. Lots of negative reward there. Finish off this third example island. Try it again. Partner thinking. And more bricks. It knows that's safe. Tries adding some ground blocks over there. Again, that's not good. So I'm going to partially give it this fourth island, and then look what happens. So this is really cool. So it added this whole section here, and it added everything in the right place locally. But notably, it filled in the gaps that I had previously been creating. Now, this isn't exactly what I wanted, but it ends up being close enough after 3.25 examples, or however you want to give that, to something that's reasonable. And then I end up using that in a design going forward. So I don't delete any of this else. I keep on moving forward. So this is a really long video. You can actually find it on my YouTube. I can send it to Miriam afterwards if she wants to share. But basically it has me making 2 levels of this thing. You can see how it sort of adapts to my design process over time. So this is sort of an idealized, at least for me, obviously, because I made it, PCGML mixed initiative tool. It's a human and an AI working together to make a thing, in this case, a game level. And you can see how, you know, the AI is learning from me. I'm adjusting myself to it, et cetera, et cetera. It's creating this thing that neither of us would have made alone. Okay, now how do I actually move past to the next slide? There we go. Okay. We can also see this more recently in something like ChatGPT. You may not think about it like this, but you are working with ChatGPT to produce some digital artifacts, some output text, right? And the way that you're working with it is you're sending it a prompt. You're saying, do this thing, and then it is sending back text. And sometimes you can iterate on that prompt, right? You can say like, no, not like that, like this, but you can't directly change the text, right? So this is a different model of sort of how that mixed initiative PCGML process could look, or generative AI, if you like. So there have been lots of attempts to define mixed initiatives, so I thought I'd just quickly sort of go over them for you. So these are things like Lubert's roles, Centaur systems, Dieterning et al.'s mixed initiative definition, that's a nice one, design-driven requirements, or COFI. So real quick, Lubert's roles. This is from 2005. And Lubert basically sat down and off the top of his head said, what are all the ways that I think a computer could like help me, right? In terms of if I want to do some task. So he imagined that a computer could be his nanny, could deal with some things that he didn't want to deal with for him, could be a pen pal, send ideas back and forth in a sort of slow loop, a coach to like give him positive motivation to do things, right? Or a colleague that he could like more collaborate with more closely. Centaur systems was used a lot in terms of chess, actually. There are Centaur chess competitions where you have a human and AI working together to play a chess game. In that case, the chess game is the digital artifact. It also tends to show up a lot in like military applications for whatever reason. But this is just a different notion of like, how could a human and AI work together, in this case, to like produce something better than either one as a system. So Dieterning et al., this was a hugely influential paper from 2017. It was just an extended abstract, actually, but hugely influential. And this basically tried to map tool usage, mixed initiative tool usage, from the human having an initiative, right? So the human getting to control sort of everything that's happening. And I called that a creativity support tool. So the computer was just acting as a tool. They didn't have any agency themselves. The computer couldn't make any changes to like the piece of content themselves directly. They were just helping out. On the other side, there was computer initiative where the human just sort of prompted or was the audience for the generation. We could call that like an autonomous generator. They call it computational creativity, though I disagree with them there. That's fine. And then you have mixed initiative, which is sort of the notion of what happens if both parties have some amount of agency over the final digital artifact. And this is what we can also call co-creative, is another term for that. I'm not going to go over this in detail, but fairly recently there were a couple of these big survey paper frameworks, this one and then Kofi, on attempting to like map out this space. This was just last year, let's look at all of these mixed initiative sort of things and try to figure out what's the space of possible mixed initiative things from this. So with that, this leads us to the approach that we used in the book, which is based on a different Chi extended abstract, on trying to map out how we do mixed initiative PCGML. And this could be used as a design tool. It could also be used as a comparison tool, as I'll show you in just a second. So basically, to talk you through this figure a little bit, hopefully you can see my mouse. We have a user on one side, so it's a human user, and we have some sort of AI system on the other side. So this is not assuming this is using a machine learning system. This could be using a constructive system or whatever. And we're going to assume that we're doing things in a turn-based fashion. So this is not simultaneous. Turn taking is a very common collaborative approach, so that feels reasonable. Then the user on their turn could have a couple different actions they could take. So they could take artifact actions, which would directly alter the artifact. So in the game design or the game level design example, this Morai Maker example I showed you earlier, that would be me drawing additional tiles onto the screen. They could also take other actions. Other actions might, for example, include hitting a big button that says end turn to prompt my partner to go, right? These are any actions that don't directly affect the artifact, but which could, you know, be part of this system. The AI, on the other hand, has artifact actions, could have artifact actions themselves, right? So they could alter the artifact directly. They could also have other actions, which might be things like signaling to the human user, hey, I need some feedback on this, or something like that. You didn't see any examples of that in the Morai Maker, but you could hopefully imagine ones. We're just saying like the AI could have a little pop-up saying, well, what do you think about this? Or what do you prefer between these two things? Something like that. It doesn't directly impact the artifact, but would be part of the same system. And then both human user and AI could have non-turn actions. So these are things they could do that would impact the design process that are not happening on their turn. So the AI, for example, might be learning live, as was the case in this RL example, this Morai Maker example. Could be learning from the prior interactions. The human user, on the other hand, could do basically whatever. You can't control humans. So they could go Google something, they could read something, they could look out their window, all these things which could impact the design process, right? So that's the basic framework that we're using here. And we can then take this framework and we can use that to contextualize what's happening in some of these systems, right? So for example, this Morai Maker system, which if you didn't get it already, is just an anagram for Mario. So it's Mario Maker, but it's more AI. It's a very bad, but I made the name too quickly for my advisor to stop me. So in this case, the human user has artifact actions. They can directly alter the artifact. They have non-turn actions. They can click any of these other buttons. You can see here, there was a run button that I never clicked, but which would allow me to play the level. That would be an example of a non-turn action or another action. There was also other actions in terms of, I didn't show you this, but you could request an explanation from the AI saying like, well, what are you doing here? Why'd you do this? Things like that. The AI, on the other hand, had no other actions. So the AI could only directly impact the artifact, or when it wasn't their turn, the AI could learn. And that's it, right? We also take a look at Tenegra. So this is a classic paper from Gillian Smith at WPI and her advisor, Jim Whitehead and Michael Matthias. But, you know, mostly Gillian. And this is considered by many to be one of the first examples of a mixed initiative level design tool. In fact, it may be the first example. And in this tool, what's really interesting is the human user doesn't get directly alter the artifact at all. So the human user only gets to change this thing down here called the beat timeline, which is basically some notion of pacing through the level that you get to alter. And that's basically it. Obviously, you can do non-turn actions, but the only thing that, you know, the AI can do is when the AI gets started, you start the generator up here, it creates the level, and that's it. Then the human user could go back and update the sort of beat thing, and the AI would change the level, et cetera, et cetera. But there's no way for the AI to do anything but generate a level, and there's no way for the human user to alter the level. So it's a very different sort of setup, which has different sort of affordances. There's also Sentient Sketchbook by Antonios Liapis, and also, of course, George Kakis and Julian Julius, but again, mostly Antonios. And this was for StarCraft low-res map generation. You can see over here. So it'd be sort of like land and different sort of resources, and the blue and the white, and the oranges would be something. I forget what it was. Apologies to Antonios. But then you can see how there's a number of interesting things going on in this setup. So the human user can directly alter, cannot directly alter the maps by changing things in the map. Oh, no, you can't. You can't. No, you can actually. Sorry, I've changed my mind several times. I'm trying to remember this. It's from 2013. Apologies, it's been a decade. Give me a break. So you can directly alter the map. So that's an artifact action. But you can also select over here a population of sort of alternatives to this map. And that's being generated all the time via this AI system. So every time the human user makes an edit here, the AI is also making a new set of possible alternatives. And the human user can then pick between them as like the next step, and then sort of choose them as their next level they should use. So that's the AI making changes to the artifact, right? All these different things. The human user making changes to the artifact. You can also see over here, there's a number of different viewing modes. So this would allow you to see things like, you know, if this was a map, what would the balance be? Things like that. So that's other actions here. And the AI is also, in terms of other actions, producing a number of metrics. You can see like resource safety and things like that. The human user has non-turn actions. So that's, of course, they can look around, they can do other things that are not engaging with the system. But the AI in this also has non-turn actions, which is basically running a search-based PCG approach to be able to generate these populations. So this is a system that's using all the sort of different components, but notably in a very different way than the Morai Maker example, right? There's no learning in this system, right? The AI can sort of propose these future children, but cannot make direct edits to the map, et cetera, et cetera, et cetera. Okay, so I have a generative AI models question. I don't know if this is going to work. I was planning on basically prompting you all and then starting to get like a multiple choice kind of question thing happening here. Maybe I'll just put the questions up and I'll ask you to think about it for a second, and we'll go over it. So these modern generative AI systems are basically these prompt-based systems, right? You, a human user, write a prompt, for example, here, professor lecturing about mixed initiative tools, and then the AI system generates like text or audio or video or an image or whatever based on it. This has become wildly popular recently. So we think of these, how would this fit into the framework, right? Would it be like A, where the human user has all the kinds of actions they can have, but the AI can only make artifact actions? Would be like B, where the human user can only sort of take other actions besides directly editing the artifact, and the AI can only impact the artifact? Is it like C, where it's that, but the AI also has non-turn actions? And is it like D, where the AI has no non-turn actions, but it has some other things it can do when it is its turn besides just generate an artifact? So be thinking about in your head, which of these four are reasonable? Okay, so I would argue that they're all like this. Why am I arguing that? Well, you know, if we take something like Artbreeder or Schumidt's unnamed GAN tool or DALL-E or ChatGPT, right? All of them work in basically the same way. The human user cannot directly alter the artifact. All they can do is write prompts. So, right, the other action is I can write a prompt. That's the only action that exists in this box. Also, of course, I can take non-turn actions. I can look around. I can think about things. I could Google something. I could look at a book, etc. The AI, on the other hand, can only generate stuff. So this is a bit like Tenegra, right? The AI only can generate a thing. That's it. That's all they can do. Notably, this AI is not learning. ChatGPT is not learning, DALL-E is not learning, et cetera. It's not learning live from you during the interaction. If somebody told you that it was doing that, they're lying. What they're doing is it's collecting a whole bunch of data, and then they're going to use that data to produce the next version of the tool, like DALL-E 3 or 4, ChatGPT 3 or 4, et cetera, right? But there's no live adaptation happening from this. So it's a fairly actually simple and basic interaction framework, right? There's one other action, there's one artifact action, there's nothing else besides that. But part of that simplicity is part of why it's so successful, or why it's so popular, because it's a relatively easy framework to set up. If they were doing something where this AI had to live adapt to you, it'd be a lot harder to be able to create a tool from it. Anyway, yeah, as I said, modern interfaces like this are all static, they're not learning live. So I know that we're next entering the question and answer phase, so I thought I'd prime the pump with some sort of suggested questions, things that you can think about. So these are things we just don't know. Given a desired user experience or output artifact, what's the best interaction framework? We don't know that right now. It'd be great to figure that out. You need to run some human subject studies. You can take examples from prior work in terms of saying, well, this interaction framework seemed to work really well, or seemed very popular or very effective, so let's maybe take inspiration from that. But we can't directly say, oh, if you want this, then do that, right? So what are the best sets of artifact actions, the best other actions, the best AI model, et cetera? So when to use static or dynamic mixed initiative PCGML tools. So when to have the AI partner learning from you. I would argue all the time, but I'm one person, right? So you don't have to listen to me. And then if it's dynamic, so if it's learning, when do you learn? So I have linked a paper there from my PhD student, Emily Helena, her recent paper at IJCAI last year, 2 years ago, something like that, on trying to figure out when's the best time to learn. Anyway, with that, I have gone for the suggested 33 minutes. So I'll go ahead and end there, and I'm happy to take any questions.
Thank you so much, Matthew. I think this might become a regular video that we have to have in this course. Really good explanations.
Thank you.
I have a few things I want to ask you, but I also want to open up the floor. And the way we do it is that if you guys have a question, I will repeat it to Matthew so that he can really hear it. Anyone right now wanting to ask something? See if there's anything in the chat. No. So I just, Matthew, did you alter the slides that you sent me? They seem so much more. No, yeah, because they seem so much more vivid when you talk to, like, you know, to them. So something I was wondering, the Morai Maker, is that something that is possible to kind of download and play with, or?
Yeah, there's a GitHub. You can use the GitHub if you like. The full sort of tool is in there, so it's usable. The only thing is that we don't have the this is for ethics reasons. We don't have the full model, so we don't have the backend AI model that was trained on a whole bunch of other people's interaction data in there. If that's something that's of interest to people, like if people would like to play around with that, that's something that I could, like, as an individual, send out, right? So that's the GitHub link I've sent. But it's not something that we make publicly available.
Oh, that would be fantastic, because we have workshops, like hands-on workshops in the course. But it's not always easy to actually get your hands on the stuff. So for us, that would be super valuable, right? Yes, there is nodding happening. So what is, like, the next step for you in your work? I know that you have tons of PhD students, and that Mike was visiting you last summer, he told us last week.
Yeah. Seth Cooper from Northeastern and Mike from King's College London were both visiting this summer, so it was a busy summer. Yeah, there's a lot of stuff that we're doing. So I have a number of students, right? And I think they all are pulling themselves in different directions, so I can sort of talk through that, right? A couple of them are about to graduate, so they're sort of settled. But the three that are mid or early, so the one is Jorge Gonzalez, And his work is really interested in saying, how can we extend a given game? So basically, how can we automatically produce DLC for a game, given an example input game? And a lot of that is thinking about questions of how do we generate stuff for people that isn't just levels. So he's looking at how can we generate like enemies for your game and new rules for your game via machine learning. I'm thinking about that in a sort of tool context. He's also thinking about 3D level generation, because people always get, frustrated with the PCGML folks that we haven't been doing a lot of 3D stuff. And a lot of that is because these things would extend naturally given data. It's just a lack of data for 3D examples, but he's got some fun stuff with nerfs there. Then there's Dagmar Lofsdotter. They're working on, they're really interested in questions around how do you do ethical generative AI stuff? So how can you ensure that you're only using things like things that are in, what's the term, the copyright term, things that are out of copyright, right? To train on, or how can you have informed consent when you're training with somebody's stuff? So this summer they were working on this really cool mobile application tool. I don't know if this is available yet, so I don't want to like blow that up if so, called ARP, in which basically you would play Exquisite Corpse. If you're familiar with the game Exquisite Corpse.
No. Have any of you?
Oh, okay.
No.
Exquisite Corpse is this art game. It was from like the Dadaists, the Surrealists, right? Around like the mid 20th century. And the idea is that you take a piece of paper and you fold it up into like thirds or fifths, and you let somebody draw only a chunk of the paper at once, right? So you're familiar with this game, you don't know the term Exquisite Corpse.
Not the game, but the thing is that we talked about that very thing earlier today in a kind of ML lecture. Yeah, so that's why there was kind of nods and laughter here. Yeah, very cool.
Cool. Yeah. So they have this mobile app for playing Exquisite Corpse with this AI system, which like learns to try to adjust to your group over time. Waiting for the data on that, which is exciting. But they've got a number of different projects in this area around like ethical animation and art generation and things like that. And then there's Emily Helena. So Emily is very much in the games area as well. They're doing things around some stuff around game level generation that will be presented at AID next week. But more recently, they've been interested in world models, which is this concept out of reinforcement learning, largely of like learning a model of the environment that you're acting in. You can basically think about if we're playing a game, we're basically learning to like clone the game as we're playing it, right? And that's been around for a while, and you can do that reasonably well. But one of the cool things that you could do if we could learn to clone the game is what if we could then generate variations of this cloned game, right? And if we could do that, well, that's all might be helpful for reinforcement learning, but it also could be really cool just for people, right? If I can have this RL agent play some video game that you think is cool, and then you say, well, what if we adjusted it in these ways, right? That would be really cool. That'd be a fun tool to be able to put in front of people. So that's the PhD students. I'll leave it there because they're all doing the longest term work. I have a lot of master's students and undergrads doing shorter term work, but it's generally in these areas of sort of like generating stuff we've never been able to generate before, or doing cool stuff with explainability and transfer learning, or like creating cool, weird experiences for people and stuff like that.
We have a question here, but I just thought that Helena's and Gonzalez's work seems kind of related to each other too.
Totally.
But yes.
When you spoke about earlier, when you spoke about mixed initiative, you mentioned different kinds of reinforcements in different ways. Is there a way of using mixed initiative without using any kind of reinforcements? Is it?
Yeah, sure. No, you don't have to do. So most of the examples that I gave, right, weren't using any reinforcement learning. I'll bring the slides back up. But right, so like nothing on this screen. Well, that's not entirely true. No. Nothing on the screen is using reinforcement learning, right? So Artbreeder is not. Shermidal's unnamed GAN tool is not. DALL-E is not. Right. running live ChatGPT's type models or Stable Diffusion type models, none of those are using reinforcement learning either, right? So that's actually the rare case. The rare case is something like this, like, Morai Maker thing, where I'm giving feedback live to this thing and it's trying to make adjustments based on that. That's actually quite unusual.
Yeah, so just for the record, the question was, if you do mixed initiative PCG, do you have to use functions for reinforcement learning or not?
Right.
Yes, another question?
Yes. Why do you think there's a debate between using the static based machine learning or when learning, or dynamic where it learns from the user? Is it an ethical question? Or it could be abused in a dynamic system?
Did you hear the question? I'll repeat it anyway.
I did.
So
Sure, go ahead.
But for the record, for the GDPR stuff.
Sure.
Why do you think that there is such a big debate between static and dynamic approaches? Is there any ethical concerns involved?
Yeah, it's a great question. So I wouldn't really characterize it as a debate, because basically nobody is using dynamic systems in mixed initiative systems. It's basically just my lab. We're the only weirdos who are saying that this AI agent should be learning from the user while it's interacting. That's not entirely true. There's actually some interesting stuff out of like psychology where they're doing some things like this and stuff like that. In terms of why do people do it or not, right? Our perspective is that the AI can adapt to how you are as a designer a lot more effectively if it's learning from you live, right? If it's the static system where you're having to adapt yourself to it, and you can see artists having to do this all the time with like Stable Diffusion or ChatGPT or whatever, right? If you've used any of these systems, you have to change how you do work to work with them, right? And that's not very satisfying for me or my group. We would prefer that the AI system has to adapt to you, right? So it's changing itself to better match how you design, right? And we have some evidence in terms of work with designers in a Kai paper and et cetera that says that like that's a better way to do it. In terms of why these big companies don't do it, it's because it would be prohibitively expensive for them, right? To train ChatGPT, to train Stable Diffusion, to train Midjourney, this takes more electricity, more compute power than like a small country, right? They just don't have the capacity to like live adapt to these agents. You can see some people doing some interesting stuff in terms of taking the weights from some of these big models, like Meta's model, and then using LoRa, low rank, I'm going to forget what this is, something. It's basically this fine tuning or transfer learning thing to try to adapt it to their use cases, right? So in that case, we can see that it would be really effective if they could do it, but it's just prohibitively expensive. So they're not doing that right now. You mentioned ethics, right? So there's basically no difference in terms of the ethics here. It could be static or dynamic, it could be ethical or not, right? Static can be unethical because they can still take all your data, and they are. Anything you're writing into ChatGPT, anything you're writing into DALL-E, they are scraping all of those prompts, right? Every single one of them, they're saving that and they're going to use that to train a future model. With you're running dynamically, right? You can have this agent learn to adapt to the person, and then you can just delete it afterwards. So we're not saving anything in terms of the interaction. You can also have it run locally on the person's machine, and they own it, right? That's their model, and that's specific to them and nobody else, right? So you can have it be ethical or unethical in either direction. That's not really an impact here.
Great answer. Nodding is happening. I can report.
Appreciate it.
Any more questions? Yes.
What is most common in use between supervised, unsupervised, and
So what is the most common in between usage of ML technologies if you compare supervised, unsupervised, or reinforcement?
Totally. So I would say that overall, pound for pound, supervised learning is the winner.
Yeah.
Part of that is just because it's so easy, right? All you need is a massive amount of data, and data is cheap, particularly if you don't care about the ethics involved of like where you get the data. So take from that what you will. But I would say that in terms of different applications, there's big changes in terms of how much are you using one or the other, right? So we can think about supervised learning as being the default. But if we're doing something like a data science problem, right? So like if I'm trying to understand who are my users, right? Or who are my customers or something like that, then unsupervised learning is used 100%, right? That's the most common thing to use. Because the answer, we don't have the answer, right? We don't have the ground truth there. So we can't use supervised learning.
Mm.
Reinforcement learning is used in any cases where we have an agent acting in an environment. So in all the automated game playing stuff, you know, think about AlphaGo, if people remember that, or AlphaStar or OpenAI 5, right? That's all reinforcement learning. Or if you think about like robots interacting in an environment, RL. Think about autonomous driving, even though that's, you know, a pipe dream, that's RL, right? Things like this, that's all using reinforcement learning. So supervised learning wins, but it depends on the problem in terms of when you use some of these other approaches.
That was a really good question and a fantastic answer. I think we should end on this high note of great questions because time is running out. But if you think of any questions after, would it be okay if I emailed you the questions
totally.
in that case?
Yeah.
Well, with that, then thank you so much for your talk. It was an honor to have you here. And
thank you all for your great questions.
Yeah, and let's hope you can hear the applause now from the room.
Thank you.
It was a loud one.
It's audible, yeah.
Okay, thank you so much, Matthew, and hope to see you real.
Yeah.
Soon. Yeah.
Hope so.
Okay.
Bye. Thanks, everyone.
Bye.